Chapter 15, Number 17. In the hydraulic system shown in the figure, the piston on the left has a diameter of 5.1 centimeters and a mass of 2.3 kilograms. The piston on the right has a diameter of 13 centimeters and a mass of 3.6 kilograms. If the density of the fluid is 750 kilograms per meter cubed, what is the height difference between the two pistons? So, we're going to have a bunch of pressures we should think about. We'll have P1 over here and P2 over here for the fluid, and we know that P1 is going to be P2 plus rho GH. All right, the pressure head of a column of fluid. The change in pressure is rho GH. If I had the two pressures, since I already have rho, I could get H. In fact, we can solve that over and say that H will be the difference in pressures over rho G. But at the moment, I don't have the difference in pressures. But the pressure of the fluid at the point, for instance, at this location, has to equal the pressure of the piston down on it, the weight of the piston pushing down. So that's pretty easy to find. We'll say that the pressure of 1 is the weight of object 1 divided by the area of object 1. So that becomes the mass of 1 times g over pi times the radius squared, but the radius is the diameter over 2 squared. So we can put in some numbers and figure out what that would be. We have 2.3 kilograms over pi. I should definitely be in meters because I want everything to come out in meters at the end, or at least be consistent in my densities in meters cubed. So I'm going to make that 0.051 meters squared, and I divide by 2 to turn my radius into my diameter into a radius, and I end up with, I had missed a factor of g in my writing, so that's why that popped up. And then when all is said and done, these numbers come out to be 11045 pascals, which sounds reasonable. And then pressure 2 is the weight of 2 over its area, which is m2g over pi times the second diameter over 2 squared. So we put in our numbers and we have 3.6 kilograms times 9.81 meters per second square over pi times, and again convert my centimeters to meters, but divide by 2 to make it into a radius, and we get 2661 pascals. All right, and now we're going to turn that pressure difference into a column height. So as a reminder, we have that pressure 1 is pressure 2 plus rho GH, which means H is pressure 1 minus pressure 2 over rho G. So it's 11045 pascals minus 2661 pascals over 750 kilogram per meter cubed times 9.81 meters per second square. And we get 1.1395 meters, which means that it really should be 1.1 meters because we only have 2 sig figs all the way through.